Okay, let me give you guys some more practice. So here you're given the displacement of anything moving in a linear fashion. So it could be a particle, it could be a car, it could be anything. So it's moving in a linear fashion. So it could move something like this. Okay, or it could move something like this, up and down, or left and right, or whatever. But all that you're given is that the displacement is given by this, and it's only valid within this range here. Okay, so you can't go back in time. So when t equals -3, it makes no sense. Okay, so the all that you're given is that this is a displacement, and this is what we want to know here. When is it moving fastest? So this is all that you're given. Okay. First, try to understand what's going on. So sketch a rough graph just to see what's going on here. So when t is small, it wants to do a linear line here. It wants to do well, the intercept is 3, a gradient of minus 11. So this here, gradient of 3, sorry, an intercept of 3, gradient of minus 11. I'm going to guess to be like this. When t is big, it wants to do a negative cubic. So a negative cubic would be something like this. Okay, so maybe it wants to do something like this, and then something like this. Okay, and then somewhere in the middle it will have a um, a, a slight positive quadratic. So maybe we can guess it to be something like this. Okay, so now remember, when it's big, it wants to do a negative cubic. So maybe we can guess it to be something like this. Okay, it's going to go up, and then this here, well, it's going to come. Well, we're going to guess it to be something like this. Okay, and because you know that there's a turning point here and there's a turning point here, you could, if you wanted to, find out the exact coordinates here and here. If you differentiate this, and then that will give, if you differentiate this here, it will then tell you the turning point when the gradient will be 0. Okay, so you could build up a rough picture of this graph inside your mind if you wanted to. Okay, but let's jump to a graphics plotter. If you were to plot this, it would look like this. Okay, so this was I guess earlier an intercept of 3 and a gradient of -11. Okay, and so somehow it will want to do a quadratic here. Oh, we made we made a bad guess in that earlier we guessed it to be something like this. You see, we guessed it. It was a bad guess. It should go over the x-axis here. But when you differentiate this, and then find the exact coordinates of the turning point, you will realize that it's a negative. It's in the negative realm. So you will realize that it must go over what. Well, anyway, if you were to draw the graph, it would look like this. And when it's big, it wants to do a negative cubic here, and then you would guess it to look something like this. Okay, so well, anyway, your displacement time graph. So this is time. This is your s here. Will look like this. Now let's try and understand what's going on here. We could say a particle moving back and forth, or we could let's just, in our case, let's try and use a car. So let's say your car here at time equals 0, your car is, hang on, let's say that the reference point here is 0. So 0 is our reference point. So this here is our reference point, 0. So when time equals 0, that means your car is already at 3. You see 5 is here, so this must be 3. That means, remember, our reference point here is 0 here, and that means this is our reference point here, 0. So at time equals 0, the car is already 3 kilometers down the line. Okay, or you can imagine this as being a particle moving back and forth, and these are microseconds or whatever. Okay, or well, in our case, we're going to use a car. When time equals 0, the car is already at 3. That means our car is right here at the moment. Okay, it's already at 3 when time equals 0. Now, as time goes on, it's moving towards 0. It's moving towards our reference point here. That means the car is moving towards 0 here. So this point here will correspond with this one here, and the time it takes to get from here to here, it's, let's say these are in hours, it's taken, let's say 0.3 hours to get from here to here. Okay, so the point is that the car is already here, so it starts here, and then as time starts, it's moving towards our reference point. Okay, it's moving towards 0 here. Okay, now it then goes past our reference point. It then goes past our reference point, meaning it moves over to here now. Okay, so that this bit here corresponds to this bit, and then it starts to turn around, and then hang on. So what's happening is that our car starts here, it heads towards our reference point, and then it goes past our reference point, and then it turns around. Already the fact that it's turning around, here the velocity will be 0, because it must come to a stop in order to turn around. Well, anyway, it's going to turn around, so that's us here at the moment. It's going to turn around and head back towards our reference point. Remember, this is our reference point. So it's going to head back towards our reference point here. So this bit here corresponds to this bit here. Okay, and then it's going to keep on moving. Hang on. It's going to keep on moving into, well, don't forget, it's going to keep on moving to the right. Hang on, this is 5, 6, 7, 7.5. I'm going to guess 7.5. So it's going to keep on moving to 7.5. So it's going to keep on moving. The car's going to keep on moving to around about here. And then it's going to turn around. It's going to turn around and then head back towards our reference point. But this time it's going really fast, because the time it takes is from here to here. So I'm going to guess this is, I don't know, slightly over 1 hour. So from here back to our reference point, it's going to travel really fast to get back to our reference point here. Okay, so that's what's happening by looking at our displacement time graph. But the question is that hang on. The question is hang on, bear with me. The question is, when is it moving fastest? Okay, so press pause and have a go. When is it moving fastest? So hang on, let me so this is your graph here. Okay, when is it moving fastest? So press pause and have a go. Okay, so to do this here, hang on. Yeah, it's quite complicated the way it moves about, but let's just differentiate it. So originally this was our displacement equation here, and then when you differentiate it, it will give you this. So when is this at its highest? So this is displacement, this is velocity. When is the velocity highest? Well, once you've differentiated it, sketch a graph, just so that you can get an idea of what's going on. So when you differentiate it, you get to this stage here, and now sketch a graph. When t is small, we want to do a straight line here, so we'll have an intercept of -11. So this is -11 here, and a gradient of +14. So it will have a gradient of +14. And when it's big, when t is big, it wants to do a negative quadratic, and a negative quadratic would mean something like this and something like this. So you would guess it to be like this. Okay, so really it boils down to you trying to find out this point here. You're trying to find out the time. So this at this time here, that's when the velocity is at its highest. So remember, because so this was our displacement. When you differentiate it once, this will be our velocity. So you can think of this as s prime of t, or you can think of it as velocity. Okay, so this is you want to know when the velocity is highest. Okay, so this is our velocity. Well, this is the highest point here. When the time, well, you're trying to find out the time. So you could complete the square on this one to locate this time here, or you can just differentiate it again, because you know that at this point here the gradient will be 0. So let's just differentiate this. Okay, differentiate it again, so it will give you this, and then find out a time when this thing here will be 0. So differentiate it again, and so you differentiate it, and then try and find out a time when this thing equals 0. So you would set the equation to 0, and then blah blah blah. So the time so the time when the velocity is at its highest would be this time here. Okay, so so this is roughly 6 point a third, so 6 point something. Okay, so what that means is sorry, what am I talking about? Sorry, hang on. The time will be this here will be 2 point something, 2.333. Yeah. So hang on, let me think. So 2.333. So time here is 2's here, 3's here, 2 and a third will be somewhere here. You see, when the car is here, that's when it's moving fastest. Okay. So what that means is that looking at this here, remember our car starts at 3, and then it heads towards our reference point, goes past it, and then turns around, and then it's heading back to our reference point. So we are here, this bit is here, and then it's going to keep on going all the way to 700 something. You see, at this point here, that's when it's going at its fastest. Okay, right here. Okay, is it? No, not right there. Sorry. It's going to be 2 and some roughly around here. It's going to be somewhere in this region here. Okay, because this is 1, 2, 2 and a bit. So maybe around. Well, it's going to be somewhere around here. Okay.